All right, today's lesson is 15.1, trig functions of acute angles. We have a definition to kind of talk about, but before we do that, I want to just do a quick review of our trig ratios, because that will help us with our new term we're going to use. So we are going to find all the trig ratios for this triangle. So I'm going to label my right angle as C. That's very often what they will do. So it's a big C, and then little c is across from that angle, and then capital A for that angle. Across from that angle is side A, little a, big B up top, and then little side B. It's very typical when they give you the sides or angles of a triangle, and they'll say the right angle is angle C, sketch that triangle. All right, so I want to find sine of A, cosine of A, and tangent of A. We will also do the reciprocal, so cosecant of A, secant of A, and cotangent of A. And then I'll want to do each trig ratio for angle B. So sine of B, cosine of B, tangent of B, and then cosecant of B, secant of B, and cotangent of B. All right, so little review. So starting up then with sine of A, if I am looking at angle A, I need the opposite side to be A over the hypotenuse, which is C. Cosine of that angle A would use the adjacent side B over my hypotenuse, C. Tangent of angle A will be the opposite side A over the adjacent side B. And then I have my reciprocal, so cosecant would be C over A, secant, C over B, cotangent, B over A. All right, if I change my angle and I'm not using A, I'm using B, now sine would be B over C. And cosine would be A over C. And tangent would be B over A. All right, then my reciprocals, C over B, C over A, and A over B. So what I want you to notice is that there are some trig functions that are equal to other trig functions. All right, you should see some identical ratios. Where else do I see A over C? Of cosine of B. So sine of A is equal to cosine of B in this triangle. Okay, you should see some other places where that is true. I should see another place where I see B over C. For sine of angle B. All right, there's some, so sine and cosine have some similarities to them within the triangle, and so do your other trig functions, like tangent and cotangent. When I use the other angle in the triangle, they would be equal. And the same thing is going to happen with your cosecant and secant. Right, so if I look at cosecant, C over A is the same as secant when I use the other angle in my triangle. All right, and then there's relationships for all of them there. I want you to notice that because that's what we're going to use in our next example here. of what cofunctions are. So cofunction identities. All right, so we have sine of angle A, we'll call it, it can be the angle A in our triangle above if you'd like, equals, it's equal to cosine if, in the case above, I use cosine of B, correct? But just a little general formula would be 90 degrees minus angle A. Let's think about why that makes sense for a second. So if I have this triangle above, I have a right angle, so that's going to be 90 degrees. So no matter what angle A is, the measure of angle B is going to be 90 degrees minus that angle. All right, so that's what that's saying. Sine of this angle is equal to cosine of that angle. And that's what we just showed in our little ratios. Okay, we also, I can write it the other way as well. So I can say cosine of A is equal to sine of 90 degrees minus A. And we saw above that cosecant was equal to which trig function? Secant if I used the other angle in that triangle, which would just be 90 degrees take away whatever that angle is. All right, same thing goes if I put secant first. So secant of angle A would equal cosecant of 90 degrees minus A. Then the last one that we saw to be true is that tangent of an angle in my right triangle would be equal to cotangent if I use that other angle. So I take 90 degrees minus that angle, and then they would be equal functions. Same way if I wrote cotangent first. Okay, so what you'll see for your examples, you will write functions in terms of cofunctions. So my first example, if I gave you cosine of 52 degrees, what would that be equal to in terms of a cofunction? So if you wanted a little visual of kind of what's happening, you have a right angle, you got 52 degrees, so it's saying cosine of this angle would be equal to sine, but of the other angle in the triangle, right? So then I got to take 90 degrees minus 52 degrees to figure out what the other angle would be in that triangle. So sine of 38. It doesn't necessarily really need any work if you kind of just understand what's happening in here. If you labeled these sides, so all students that will forget, they can't remember which trig functions are equal to each other, you could label your sides, you know, x, y, z if you wanted to. Take cosine of 52 degrees and write that as x over z. Then figure out, well, which one of them, using the other angle, would make sense to still be x over z. So if I'm in this angle, I need the opposite side over the hypotenuse to be equal, so that makes it sine. All right, that helps you to kind of sketch that visual. If you're forgetting your cofunction identities, you can do that. So my second example, tangent of 71 degrees. If it's helpful to sketch something, go for it. If you understand what's happening, that's fine. Tangent's going to be equal to cotangent if I use the other angle, other than the right angle, within my triangle. So that means that third angle would be 90 minus 71 degrees. So cotangent of 19 degrees would be equal to tangent of 71 degrees. Last example here for this one. So secant of 24 degrees. I'm writing what it would be equal to in terms of its cofunction. So secant and cosecant are equal as cofunctions, and then I gotta find, well, what's left over from 90 minus 24 should be 66 degrees. And that would be my answer. All right, so not a lot of steps there, but we need to be familiar with which ones would be equal. I have a lot of students that will take it away from 100 degrees, and they get things wrong that way. And just because of 100 seems like a nicer number to work with than 90, but not sure. All right, so here's the other part that we're going to need in this section. We want to recall back from geometry your special right triangles. All right, so you had two of them. You had your 30, 60, 90 triangles. All right, so if this is 60 degrees, this is 30 degrees. And then you had your 45, 45, 90 triangles. So these are both 45 degrees with a 90-degree angle. All right, and you had relationships between their side lengths that were always true. Maybe you proved that in geometry as to why they were true, or you used Pythagorean theorem multiple times and you could see some patterns that showed up. We're not going to go over that part. But if you had the relationship for the side length, so we call that x, so no matter what that is, that's the shortest side of my triangle because it's across from the smallest angle. I take 2 times the value of that short leg to get the hypotenuse every time. And then for that longer leg, I take that short leg times the square root of 3 every time, no matter what number I would have for the short leg. And that was the relationship. For your 45, 45, 90 triangle, it was isosceles, so these are the same length. And then the hypotenuse was that length times the square root of 2. All right, I'm sure you learned this. Maybe you spent a few days on it and you moved on and you just memorized it, and now you don't remember it since 2 years ago in geometry or whenever that was. All right, so maybe it's something you need to remember again. All right, but what we're going to do with it, if we were creating a little triangle here, so we will use x to be 1 in our triangle, so that will make this 1. It'll just be the square root of 3. We'll use 2. These are both 1, and that's just going to be the square root of 2. All right, so we're going to use that for what we're going to do next. All right, so we're gonna make a little chart here. I'm gonna make a chart of all 6 trig functions across. So I'll start with sine of theta, cosine of theta, tangent of theta, and then I'll do their reciprocals in that order. So cosecant, secant, and cotangent. All right, so I'm gonna make a little table here. The angle I want for theta will have 3 angles, so we're gonna have 30 degrees, 45 degrees, and 60 degrees. So if you've got lined paper, yours might look a little bit nicer than mine's gonna look. That's good. All right, this table will be helpful for us in our next few examples. So I'm going to refer back to those triangles above. All right, so in this table, I'm looking at sine of 30 degrees in this first spot here. This first spot. So if I'm looking at the 30, 60, 90 triangle, I've got my 30 degrees. So the opposite side would be 1, and my hypotenuse is 2. So sine of 30 degrees is 1/2. All right, if I do cosine of 30 degrees, I want the adjacent side, which is the square root of 3, over the hypotenuse, which is 2. For tangent, I'm going to use the opposite side, which would be 1, over my adjacent side, which is the square root of 3. Remember, we're not going to leave it as 1 over the square root of 3. I'd multiply the top and bottom by the square root of 3. So I'm actually going to use the square root of 3 over 3. Okay. So then I'll just use the reciprocals for cosecant would be 2 over 1. Secant would be 2 over the square root of 3. So that means I'll have to multiply the top and bottom by the square root of 3. So that would equal 2 square roots of 3 over 3. And cotangent, instead of flipping the square root of 3 over 3, I'm going to have to rationalize that denominator as well. So I'm just going to flip over 1 over the square root of 3. So then I'm just using the square root of 3. All right, now if I'm using 45 degrees, I'm in my triangle over here. So I have 1 over the square root of 2 for sine. Remember, you will not leave it like that. I'd multiply the top and bottom by the square root of 2. So that would give me the square root of 2 over 2. For cosine, it's going to be the same thing because it's 1 for your adjacent side over the square root of 2. So I'm just going to write the square root of 2 over 2. For tangent, I would use the opposite side 1 over the adjacent side 1. And then I'll use my reciprocals. So I want to use the reciprocal for 1 over square root of 2, because when I just flip that, I would get square root of 2 for both. And then cotangent flipping 1 over 1 is still 1. Now for 60 degrees, you can go ahead and go off of this angle right here and use your opposite over hypotenuse, all that stuff. Or we could use our cofunction identities, right? So if I have sine of 60 degrees, that has to be equal to cosine of 30 degrees because their angles would add up to 90 degrees. All right, so then the same thing goes for cosine of 60. That has to equal sine of 30. Tangent of 60 would have to equal cotangent of 30. And then I can use those reciprocals. So cosecant would be the 2 square roots of 3 over 3. Secant would be the 2 over 1. and cotangent would be the square root of 3 over 3. We're going to make this table multiple times, and we're going to use it to help us answer some questions. So in my examples, on problems on your homework, you're going to be asked, well, what is the sine of 30 degrees? And you'd either use your special right triangle or you use this table and go, well, it's 1/2. All right, these are your common ratios. These are the ones that show up a lot. We're going to use them again tomorrow. So you want to get familiar with them. You want to get familiar with how they look. And then eventually you start to know some of these. All right. I was taught to memorize sine of 30 degrees. And then after that, you can kind of figure out a lot of the other ones afterwards. But you want to be familiar with them as soon as you can. Okay. You can use your table for right now and doing your homework when you have some examples. And it's going to ask you for an exact answer. So if I asked you for a cosine of 45 degrees, the exact is the square root of 2 over 2. So make sure you're using that in Math Excel. You're using the radical. You're using that fraction. Okay. All right. That is it for our lesson today.